Hi guys, welcome to another episode of Kickin with Karan. Today I have Ian from Red Bull Racing. Hi Ian, thank you for joining me.
Hi, Karan. Thank you for inviting me.
Absolutely. I know it's a busy season, so I appreciate you spending a couple of minutes. It's been an exciting season. Congrats for last season. So yeah. So for my audience, Ian, why don't you go ahead, introduce yourself, what you do at Red Bull.
Yeah, sure. So my name's Ian. I'm an engineering manager within Oracle Red Bull Racing. So my group looks after all of the engineering software that runs off of the car. So there is lots of simulation, data processing, data visualization. So essentially all the data that's coming off of the car, out of the wind tunnel, off of engine rigs, CFD simulations. It's a pretty wide remit that we have. Actually, everything that runs on the pit wall as well. So super interesting, really exciting, and yeah, just a fantastic team of people to work with, kind of across the business, really.
Right. Is it fair to say that you do a lot of traditional HPC?
Absolutely, yeah. So we don't get stuck into the actual simulations themselves. We more write the frameworks around, how to actually model the flow physics over the car. So that's done by people that are way smarter than I am. Yeah, so the focus of us is all about surfacing, capturing, visualizing the data. But HPC is a huge part of that space for us.
Got it. And so, you talked a little bit about sort of the simulations and kind of the design of the car, potentially the engine block, et cetera. How are these decisions kind of like, how do they sort of flow into the race themselves? Like, do you really see a lot of change in terms of the changes perhaps you make on the car, in terms of the parts on the car, but also maybe engine changes? Do you sort of like take those data back, simulate it again, and then re sort of engineer the parts? Like, how does that flow work?
Yeah, that's a great question. I think it's always really interesting to think about this kind of stuff in the kind of lifetime of a component. So if you take something like a front wing is a quite a good example. So it's quite a complex aerodynamic structure. It's got many parts to it. So it typically starts with somebody designing in CAD, and then from that model you can then run CFD simulations around whether you think that's going to give you some performance. And if you think it does, then you generally generate a 60% model of this thing, and you can go and take it over to our wind tunnel, and then you can run this thing in the wind tunnel and actually see the air flowing over that component, see if it's giving you the performance you were hoping for. And you can kind of compare that back to the CFD simulation and kind of iterate the design slightly. And that then kind of focuses you in on, a better design of that component, which you can then model kind of on the vehicle in the vehicle simulator. So you can actually, pop a driver into a vehicle in the loop simulator and model how that front wing is going to perform. And then again, you can kind of compare that data to data you've captured off the wind tunnel to see, does it seem to align? And so you have this kind of quite a long lifetime of when a component starts as an idea of somebody's computer to the point it actually hits the track.
Right. Would you do these kinds of things multiple times during the season, or is it sort of like it's really at the start of the season when you're building the car, and do you have opportunity to sort of like modify parts or components of the car, as you see like the performance of those parts and components, and then sort of like almost like rapid prototyping in some sense?
Yeah, absolutely. I mean, there's an element of that in the sense that you want to rapidly prototype your components as they develop according to the knowledge you've captured, in these different environments. As you learn data coming off the wind tunnel, you might see a different behavior actually on the track when you're doing it for real. But the other part is that the races kind of involve fundamentally different cars. If you think about a track like Mexico and a track like Texas, they're typically, a week or maybe 2 weeks apart, but there's almost 1.5 kilometers in altitude difference of where the tracks are. And that has a massive effect on your aero package. So you have to completely change how the car is designed from one race to the next. Sometimes around what you've learned in the components, and sometimes around the bespoke package for that track.
Got it. That makes sense. And obviously, we're partnering together from a technology perspective on the cloud. And how does sort of having access to sort of, in some sense, well, nothing's infinite, but in some sense, bottomless compute capacity help you in terms of these simulations, but also perhaps CFD or other types of workloads that you're running?
Yeah, I mean, having that capability is amazing. I mean, one of the things that OCI gives us is that ability to kind of scale horizontally. So a great example is some of the simulations we do in the race strategy. So we run Monte Carlo simulations based upon tire strategy kind of during the race. And the ability to be able to scale that out to include more simulations and more parameters is just so powerful. It allows us to really inform the decision of people that are under huge amounts of pressure and very short timescales in which to decide what to do next.
Got it. And so you can't take it almost has to be real time in some sense, right? So you really have to scale incredibly high to be able to get those results quick.
We do kind of pre-event simulations of what we think our optimum tire strategy is going to be in this scenario. But it's a classic example of, the best laid plans don't really survive first contact with the enemy. It's as soon as you've actually started the race, your plan can be completely out the window, and you have to be able to respond and adapt to that as quickly as possible.
I'm guessing it's most of the time anyway, right? I mean, you could have rain, you could have different weather patterns, you could have,
accidents as well. Exactly. Yeah, there's so many variables in this space that some things you can predict for, or you can have a good guess, and some things will totally blindside you. So the key to our tools is all about informing that human decision making.
And where are some, I guess, last couple of questions, where are some improvements that you think that can still be made to sort of make those decisions or the simulations, or just the overall kind of like strategic nature of this thing? What are some greenfield opportunities to make all this better, I guess, in some sense?
Yeah, no, great question. I think really in this space of the race strategy simulation, it's about trying to buy more time for that person to actually make a decision. When you've literally got tens of seconds to make a decision that's going to cost you, millions of dollars potentially, a few extra seconds actually has a massive benefit in just confirming that your gut feeling is tying up with what the data is telling you. So the ability for us to scale those simulations out to include more parameters and more teams in the variability, and more parameters in the sort of vertical complexity, that's really where we're going to see big benefits in the future.
So in some sense, even more data complexity and more parameters in general.
Yeah, absolutely. Yeah.
Got it.
The key is being able to simplify that, to present it. So taking more data in, but summarizing and presenting it in a more concise manner.
Got it. Okay. Well, this was obviously very enlightening, especially for me on the infrastructure side. It's interesting to see how some of these components that we sort of provide to our customers from just a pure commodity infrastructure point of view make their way down all the way to a racetrack. So it's very, very interesting to see that. So thanks again for joining me, Ian. Really appreciate the time. Luck for the rest of the season. And we'll all catch you next time on another episode. Bye.
Thanks, Karan. See you later.
Cheers.